In this video, we're going to go over permutations. We're going to start off with factorials. So what exactly is a factorial? Well, a factorial of a number, we're going to use the number n. We don't actually have a number there. It's going to be written as n factorial, which is just an n with an exclamation point. And it's going to be the product of all natural numbers starting from that number all the way down to 1. So in a scenario we don't actually know what that number is, you could start off with your n, like they did here, and then you're going to subtract 1, which is n minus 1, subtract another 1, which becomes n minus 2, and then eventually you'll keep going until you stop at 1. Some other key things to note is going to be that our 1 factorial is going to be 1 and 0 factorial is 1. But like I said, factorial is just saying that we're going to start at that number. So for example here, if we have 5 factorial, 5 factorial, this would be our 5 times 4 times 3 times 2 times 1. All right, moving into our permutations. So a permutation is the total possibilities when order is important, such as some keywords of arrange, order, rank, lineup, etc. We do have a few different formulas depending on the scenario. So an arrangement where all of your n objects, everything that's available to you is being used, can be written as we have our p n comma n, because you're using all of what is available, which just results into our n factorial. Then we have our arrangement of n objects, but we're taking r of them at a time, so we're not using every single one of them. And so for that write-up, we would do our p n comma r. And just to clarify, your r should never be greater than your n, because it's not possible to take more than what is available to you. And then we have our formula, which is n factorial over n minus r factorial. Then we have our arrangement of n objects, where some of your objects are going to be the same. And so when there's repetition, we have our n factorial divided by, and so then we have an S1 factorial, S2 factorial. This is going to be the factorials. So we get these numbers by looking at what repeats and how many times it repeated. And we'll see an example like this down below. And lastly, we have our arrangement of n objects in a circle where relative order is important. So to solve for that, you would do n minus 1 factorial, because when you have a circular rotation of it, so for example, let's say I have a circle here of A, B, C. And if I rearrange by just shifting them downward, A, B, C, have I actually changed my outcome? No, because I'm looking at it, but just at a different angle. So it's the same exact thing. And so what we do here is we just subtract out our minus 1 to just say that like one person could be staying still in a sense, and everybody moving around, or just because it is our, n factorial divided by n, because this arrangement will happen the same amount of times as what my n is. All right, so now let's look at our fundamental counting principle. So you can use the counting principle to find the number of outcomes when multiple events occur in a sequence, each with its own set of choices. If one activity can occur in m ways, and another activity can occur in n So they're just saying, a different amount of ways. Then both activities can occur by just multiplying the number of ways together. So your M times N. So let's look at some practice problems down below. We have in number 1, how many different ways can 8 books be arranged on a shelf? Well, this would be that P where we've got our 8, 8, which is just the same thing as 8 factorial. And if you plug that into your calculator, you're going to get, we've got 40,320. Then moving into number 2, find the number of possible seating charts if there are 10 students and 12 chairs. All right, so they're trying to trick you in this one. So here we have our permutation or order matters, because I could use the same amount of people but switch them up and I have a different outcome. But they're tricking you because they have that 10 first, 12 second. But what's your total amount that you have to pick from? I have 12 chairs I have to pick from, but I'm only using 10 of them. So that would be my permutation 12, 10. And when you plug that into your calculator, you're going to get, we have 239,500,800. All right, moving into number 3, we have find the number of different 6-letter arrangements that can be formed from, sorry, there's a typo there, the letters in the word, and we're going to start off with monkey. All right, so for monkey, we have 6 letters. We would just do 6 factorial, because we're using all 6 since they don't state otherwise. And so that's going to just give me 720. But when we move into Amazon, we would still have that 6 factorial, but what we notice here is the fact that our A is going to repeat twice. So we are going to have to use that formula that was mentioned up above with our repeats and divide by the number of times that letter repeats factorial. So here my A repeats twice, so I'm going to have a 2 factorial. And so this is going to give me 360. The reason why we do this is because if I take that word Amazon and I, rearrange and I switch those 2 A's, the 6 factorial is saying that that's something different, but in reality it isn't. So in order for us to help cancel that out, we are just going to divide by the number of times it repeats, factorial. And then if you have multiples, then you're just going to keep multiplying by that same idea. So for example, when we move into banana, okay, we have that 6 factorial, but our A is going to repeat 3 times, so we're going to have a 3 factorial. And my N repeats twice, so times 2 factorial. And when you plug that into your calculator, you should get 60 as your answer. So just keep in mind, if you have the repeats, make sure that you are using that division so we can cancel out the fact that we don't actually get a new result when we just switch the 2 letters that are the same. So for example, that Amazon and Amazon. Okay, looking at number 4, we have find the number of ways 5 people can be seated around a campfire, So this is going to be that circular formula that we said earlier where we have to do our n minus 1 factorial. Okay, because once again, remember, if we take the same 5 people and we have our here circular kind of sitting around that campfire, we've got A, B, C, D, and E. And all I do is shift them down. So A, B, C, D, and E. They all have a new seat, but we haven't actually created a new way of sitting around the campfire because it's just the same thing, but me looking at it from a different angle. So it's different when you're sitting in a row because when I shift down, so A, B, C, D, E, I shift down, we've got B, C, D, E, A. We're going to have a new outcome, but in the circular rotation, that doesn't actually happen. So once again, this is where we would need to do the n minus 1. So we're going to have our 5 minus 1 factorial, which is just going to give us 4 factorial. And that's going to be equal to 24. All right, looking at number 5. With number 5 here, I'll write out what the answers are, but this is just a matter of you plugging into the calculator and getting practice with it so that you're not kind of super slow with it when it comes to a test or quiz time. But all you're doing is just taking your P permutation 5, 2, your N, R, and plugging that into your calculator. And to make sure you're getting the correct answer, I'm going to write out that that's going to be equal to 20. Over here in part B, this is your N, this is your R. Remember, it's just a different way of writing it. And so you can set it up the same way in your calculators, but that's going to be equal to 840. Part C, once again, just plug it into your calculators. When you plug that in, you should get 30 if you've plugged it in correctly. And in D, you should get 2.8. For E, you're going to get 2. And then for F, you're going to get 126. Okay, like I said, for those, I kind of just sped through them because it's just a matter of you plugging into calculator. You're really not going to see in my videos me being able to plug into it because I don't know how to show that. But a good online calculator, in my opinion, is going to be the Desmos Scientific Calculator for that. And you just need to go to the function and you'll see your permutation and combination there. All right, so now let's look at the next set of problems. We have answering the following questions using the appropriate permutation formula. All right, so for number 7, how many ways can 9 baseball players be lined up to bat? So just to clarify, as I'm working through these, why order matters. So here, my N and my R would just be 9. But order matters because if I pick the same 9 people and I rearrange them, I have a different outcome because if I picked first in one situation, you're batting first. But if I pick you second, using the same 9 people, then there's a different outcome because you're not batting first, you're going to be batting second. So for this answer, when you plug that into your calculator, your 9 factorial, you should get 362,880. Okay. Number 8, we have how many ways can 6 students be seated in a row? So because we're being seated in a row, this would just be that 6 factorial, or you've got your 6, 6 for your N and your R, which is going to give you, we'll have 720. And to clarify, this was for my row. When we move into for our table, okay, we would have that 6 minus 1 factorial, which is just going to give us 5 factorial. And when you plug that into your calculator, you're going to get 120. All right, we've got number 9. How many 6-digit license plates can be made if the first digit must not be a 0 and no digit can repeat? So for this one, it can be a little tricky. We have 6 places that we can pick for. And when we pick for my first one, they said that we just can't be a 0, which means it could be 1 through 9, which gives me 9 options. When I go to make my next choice, I know it can't repeat. I know I have one less, which would be 8, except for I can now have that 0, which means I go back up to 9. So we'll have 9 times, and then here's where we will go ahead and move downward to that 8, 7, 6, and 5. So we're multiplying all of these out. This is going to also just be 9 times, and we have our permutation 9, and we're picking 5 of them because that's where we start that moving downward. And when you plug this into your calculator, you're going to get 136,080. All right, so now let's look at our next one. We have number 10. If there are 9 people, how many ways can 4 of them be seated in a car? 2 in the front and 2 in the back. All right, so here we have a permutation because the order doesn't matter. I can pick the same 4 people and have a different outcome because they could be seating in different spots. So with this, we would have our 9 people as our total. Oops, sorry. And we would be picking 4 of them to be seated. So plugging that into my calculator, I'm going to get 3,024 as my ways that this can happen. Okay, moving into number 11. How many permutations of the letters we've got rearrangement are there? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 different letters I can pick from. Now remember, we have letters and some of them are repeats. So we got to go through and divide by how many times it repeats. So we have that R in there 1, 2, 3 times. Then we have E in there 1, 2, 3 times. We have that A in there 1, 2 times. And then we also have that N in there 1, 2 times as well. Okay, so when I plug this into my calculator, I should get, we've got 43,243,200. I will say with permutations and combinations, which is the next lesson, working through these, you can get some really big numbers. You want to be very careful when you're writing them out, that what you're writing as your answer does match what's in the calculator, and that you're not accidentally skipping over or rearranging the order of the numbers of what you see. So just be very careful. All right, moving into the last one for this side, we have if 18 gymnasts are competing in an event, how many ways can gold, silver, and bronze be awarded? So this is going to be a permutation, and I'm trying to explain this a little bit just because in our next lesson, you'll see the combinations and you'll understand why. But this is a permutation because order matters. I can pick the same 3 people. So for example, we'll go Taylor, Jordan, and Lindsay. And in this situation, Taylor's got first, so she's going to get gold. Then we got Jordan as our silver and bronze for Lindsay. But if I just make a minor tweak to it, so Taylor, got to keep myself first. Then Lindsay. And then Jordan. I have the same 3 people, but my order matters because now Lindsay is got silver and Jordan has bronze, which means my outcome is different. So this is why it's a permutation. And my N is going to be 18. And for my R, I would be picking 3 people, 1 for each place, which should give me 4,896 ways. All right, so let's move into the back side of our notes. So answer the following questions using the appropriate permutation formula or the counting principle. So we have number 13, a manufacturer makes sneakers in 5 colors, available in 3 styles and 2 fabrics. How many types of sneakers does the manufacturer make? Okay, so here my choices that I have to make have nothing to do with each other. And so this is going to be that counting principle where I can just multiply my number of options together to figure out how many ways I can do it. So here I would just start off with 5 times 3 times 2, which is just going to give me 30 as my answer for how many types. Okay, moving into number 14. Each of 6 questions on a multiple choice test have 4 possible answers. If all questions are answered, in how many different ways can the test be completed? So this is also going to be a fundamental counting because me making my choice on the first question has nothing to do with when I move into the second question, me making my answer choice for that one. So with this, I would just multiply 4, because I have 4 options on the first question, times 4, once again, 4 options. And I'm going to do this 6 times because I have 6 questions. But another way of writing this is also just going to be 4 to the power of 6, which is going to be equal to 4,096. Moving into number 15, how many different license plates can be made if they must have 3 letters followed by 3 digits? Okay, so when I make my first choice, we know that we have to pick a letter, okay? And there's going to be 26 letters in the alphabet. So I have 26 times, when I make my next choice, I have also 26 times another 26. Then when I move into my 3 numbers or 3 digits, I could pick 10 times 10 times another 10, because they don't mention here that they cannot repeat in these scenarios. And so therefore we could still be using the same letters over and over or the same digits over and over. So this is just going to be kind of like the one above it, where I could do 26 to the power of 3 times 10 to the power of 3, which is equal to, we've got 17,576,000 as my answer. Okay, but when we move into number 16, it's a very similar situation. How many different license plates can be made if they have 3 letters followed by 3 digits and no letter or digit is repeated? So here you would start off with that 26, then you would have 25, one less, and then 24 times 10, 9, and 8. Okay, so this is going to be, we've got our permutation of 26, pick 3, because we're stopping after we make 1, 2, 3 choices, times, and then we would have that 10, and then we would have the same picking 3, 1, 2, 3. Just to clarify, because I didn't mention it earlier either, but we're getting 10 because we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's giving us our 10 options. And so when I plug this into my calculator, I'm going to get, we've got 11,232,000 as my answer. All right. Moving into number 17, find the number of different ways you can arrange the letters in the word cloud. Okay, so we've got cloud, which has 5 letters in it. So that would be 5 factorial. Just double checking, we have no repeats, so we don't have to divide. And so when I plug that into my calculator, I just get 120 as my ways that I could do that. Okay. Number 18, the letters A, B, C, and D are used to form 4-letter passwords for entering a file. We've got how many passwords are possible if repetition is allowed, and then, how many are going to be possible if repetition is not going to be allowed. So, starting this off, if we can repeat, so I'm going to have my repetition. Oops, I do not know how to spell repetition. Okay, I would have the 4 times 4 times 4 times 4, which, once again, if you wanted to, you could do 4 to the power of 4, is going to be equal to 256. Okay, then if we are not repeating, so no repetition, then we are going to just go ahead and go from 4 times 3 times 2 times 1, which is the same thing as my 4 factorial, and we would get 24. All right, this next one can be a little tricky. So we have the bride and the groom and 8 members of the bridal party are seated at a round table. So we might possibly have to do the n-1 factorial because we have the round table. The bride and the groom have specific seats. So if they have specific seats, they are not going to be moving. So when they're asking how many ways can the bridal party be seated around the table, we actually are not going to do the n-1 factorial because we have 2 people that are going to stay put no matter what, and we're just going to be rotating those people around them. So for example here, and I'm not going to do it with 8 because that's going to be really hard to do. But if I had A, B, C, D, and let's say that my A had to stay put and everybody else moved, so D, B, C, no matter how I look at this, this is never going to be the same thing as what I had before. It's going to be different. So we don't have to do the n-1 when somebody is staying put, when not everybody is being rotated around that circular kind of motion for the seating arrangement. And so we are just going to do our 8 factorial which is our 40,320. All right, so just keep that in mind with your n-1 formula. It's only if everybody is moving around so that everybody is being like shifted and you still have the same outcome. All right, number 20. We have find the number of different ways that you can arrange the letters in the word hippopotamus. Okay, so hippopotamus, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters. So we're going to start with our 12 factorial. And then remember, we can't stop there unless we've confirmed that there's no repeats. So if I look here, no H's, no I's, but I do have 3 P's. So we're going to divide by 3 factorial. Let's double check. We do have 2 O's. So a 2 factorial. And that is it for our repeats. So we would take our 12 factorial divided by 3 factorial times 2 factorial. And that's going to give me, we'll get 39,916,800. Sorry, I was double checking I wrote that down correctly. All right, we got 21. How many ways can 7 students line up at a ticket booth? Okay, so we have no mention of, not using everybody. So we're going to have our permutation 7, 7. We're using everybody, which remember just results into that 7 factorial. And that will be equal to 5,040. Okay, we're almost done. How many ways can a 5-position lineup be chosen from 8 players? So they are specifying that we're going to have 8 to pick from, so that's my N, comma, we're only going to be using 5 people. That's going to be my R. So plugging that into my calculator, I'm going to just get 6,720. Okay, number 23. The manager of a baseball team wants the fastest player up first. Okay, so if a lineup consists of 9 players, how many different lineups are possible? Well, keep in mind, when you have your lineup and you want the first person to be the fastest, there's only one player that could be the fastest. So I'm going to have a 1 times. Then when I pick my next few people, I'm going to start off with 8 times 7 times 6, 5, 4, 3, 2, and then 1, which this is just resulting into 1 times my 8 factorial or 8 factorial. And that's going to give us 40,320. Okay. 24. We have a code is formed so that each code has exactly 4 letters. The code cannot start or end with a consonant. So for those of you who do not know what that means obviously we're going to be having to start with a vowel. A vowel is our A-E-I-O-U. So we've got if the letters C, N, and Y are excluded, how many different code words can be formed? All right. So when I pick my first option, I've got 5 that I have to pick from. Okay, like I said, we would have our A, E, I, O, U, our vowels, because our consonants are everything else. Then when we make our next choice, it can be anything. They don't mention it can't repeat, so we can, use the same thing over. But we cannot use the letters C, N, and Y. Therefore, I've got 26 letters total, 3 excluded, so I only have 23 to pick from. Okay, times, we would have another 23, but at the end for my fourth one, we would have 5 again, because remember, it would have to be a vowel. We can't have a consonant there. So plugging into my calculator, we got 13,225 as our answer. All right, our very last problem for these notes, we have how many ways can 3 identical pen sets and 5 identical watches be given to 8 graduates if each graduate receives only 1 gift? All right, we have that lovely term in here of identical. They're the same exact thing. So we would just do our 8 factorial, but we have to divide because 3 are identical for the pens and 5 are identical for my watches. So we would have 3 factorial times 5 factorial in my denominator. And so plugging this into my calculator, I'm going to get 56 as my answer. All right, so I do have some extra problems I forgot I did want to go over. And so we're going to start off easy with this first one of just our 6 factorial, just so we get an idea, divided by our 6 minus 2 factorial. Okay, so we are going to evaluate these problems. And so to do that, we would have our 6 factorial over, simplifying, we would have 4 factorial. So what we're going to do is we would just expand out that 6 factorial until we get to 4 factorial, and it can cancel out with the 4 factorial in my denominator, right? So we would do 6 times 5 times 4. We can stop there. We can do that factorial. It keeps going. And divide by the 4 factorial in my denominator. They should cancel each other out, right? And so I'm going to end up with just 6 times 5 to give me 30. So I'm starting off with this first because it gets a little more confusing, but if you understand the basics, when we come to our expressions, it won't be as bad. So here for number 2, I'm going to put, we've got 2k factorial divided by k minus 3 factorial. All right, so 2 times k factorial is just 2 times, and then the k factorial by itself, over my k minus 3 factorial. Make sure you have that in parentheses. Without the parentheses, so I'm going to write it and then I'll erase it. So without my parentheses, you're only saying k minus and then the 3 factorial, which would be 3 times 2 times 1. But that's not the case. So we want to make sure that we're rewriting it with our parentheses so we don't mess that up. Okay, so like I mentioned before, we are going to expand out that k factorial until we see the overlap where it's the exact same thing as that k minus 3 factorial in my denominator. So what we would do is we would start with our k, and then as you see up above, right, we're going from 6 times 5. Well, how did I get to 5? I'm subtracting 1 from here to get this new number. Same idea again, I would subtract 1 to get that next number. So I would do k minus 1 times, and then k minus 1 minus another 1 just becomes a minus 2. And then we would get minus 3, which is where we would stop because we have that factorial in our denominator. We want them to match up. Okay, so here now we have those 2 factorials in common. We can cancel them out, and we're going to be left with 2 times k minus 1 times k minus 2 as my answer. And we're going to leave it like this. I'm not going to ask you to FOIL it out. mainly because I might give you some really big ones and we don't want to deal with that. I would rather just you understand the concept of it instead of having to waste your time of foiling it out. So you can leave it just like this. This would be my final answer. And so that is it for our lesson over permutations. Hopefully this helped cleared up any questions you had on those practice problems.